Good morning, my YouTube viewers. We're going to do a hypothesis test in this particular video, and we're going to be talking about people who prefer tea over coffee. So the practice question that we have to go over is 60% of people prefer tea over coffee. A survey of 500 people shows that 280 people prefer tea over coffee. And so we're going to conduct a two-tailed z-test, and the null hypothesis is P equals 60%, and the alternate hypothesis is Z does not equal 60%. So we're going to write a program in Python to solve this problem. And we're going to, in order to execute the program, then what we're going to do is we have to import 3 libraries. So the 3 libraries that we're going to import are NumPy as NP. NumPy is a numerical library that performs numeric computations. It creates NumPy arrays, and it also creates distributions. Then we're going to import scipy.stats as stats. So scipy is Python's scientific library, and stats is a statistical module within scipy. And then we're going to import matplotlib.pyplot as plt, which is our visualization library. So now what we're going to do is we're going to set our parameters. So population percent is 60%. Sample size is 500. Sample percent is 56%. And your alpha, which is your significance level, is 0.05. Okay, now we're going to calculate the standard error. So standard error equals np.square root, and then it's brackets population percent times 1 minus population percent. So that's 0.6 times 0.4 divided by sample size of 500, and then you take the square root of that. And then when you take the square root of that, you get a number of 0.2191 because I calculated it before I made this video, and you can see right here it says 0.02191. And then after we have calculated the standard error, what we're going to do is we're going to calculate our z-score. So z-score equals sample percent minus population percent. So that's going to give you a value of 0.04 divided by standard error. And then so you're going to come up with a figure of 1.8257, and you can see I've got the 1.8257 on my calculator because I calculated it. Now we're going to calculate the p-value for a two-tailed test. So p-value equals 2 times brackets 1 minus stats.norm.cdf. So norm is a normal distribution, which is also called a z-distribution, and CDF is called cumulative distribution function, brackets ABS, that's absolute value of your z-score, because your z-score is a negative value in this instance. So we're going to print the z-score and the p-value, and we've also previously printed the standard error. So what we're going to do is we're going to analyze our p-value. If the p-value is less than alpha, then you're going to 0.05, then you're going to reject the null hypothesis because there is a significance difference between the population proportion and the sample proportion. If the p-value is greater than alpha of 0.05, then you're going to fail to reject the null hypothesis. There is no significant difference between the population proportion and the sample proportion. So now what we're going to do is we're going to plot these values onto a graph. So x equals np.line space brackets -4, 4, 1000, y equals stats.norm.pdf x. So norm is your normal distribution, PDF is probability distribution function. So we're going to plot the standard distribution, standard normal distribution, plt.plot, brackets x, y, label equals standard normal distribution, color equals blue. So now we're going to shade our critical region. So z critical equals stats.norm.ppf. So norm stands for normal distribution. ppf means percentage point function, brackets 1 minus alpha divided by 2. And plt.fill between, brackets x, 0, y, where equals x is less than or equal to neg z critical, or x is greater than or equal to z critical, and color equals red, alpha equals 0.5, label equals critical region. So now we're going to mark the z-score on the plot, plt.ax line, brackets z-score, color equals green, line style equals dashed, line width equals 2, label equals z-score. So now we're going to add titles and labels. Title is two-tailed z-test. X label is z-score. Y label is probability density. And then you get your legend. And so now we're going to show it. So you've got your standard of error of 0.0219089. You've got your z-score at -1.8257. You've got your p-value of 0.0679. Now the p-value is greater than the alpha of 0.05, so that means you're going to fail to reject the null hypothesis. There is no significant difference between the population proportion and the sample proportion. And this is the chart, the diagram that we have made to show our work. So your blue is your standard normal distribution, your red is your critical region, and your green is your z-score. So you can see here that the z-score is 1.83 negative, and your critical region starts at -2. So your z-score is just before the critical region, but it did actually make the critical region. So we failed to reject the null hypothesis. So that concludes this video. The next video is going to be another hypothesis test, and I hope you decide to watch it.